Hi, I'm Chuck McLennan. As you know, one of our main goals here at Buick Know-How is to bring you timely information that you can put to immediate use in your job. As we tape this Know-How release, springtime is just beginning here in the Motor City. But pretty soon, air conditioning season will be here all across the country, and I'm sure many of you have already done some AC service by the time you see this. In this program, we'd like to provide sort of an AC refresher. First, we'll go on location to a dealership and get some real-world tips about the basic diagnostic techniques. Next, we'll go to a local college to review the procedures for using the ACR4 station to recover and charge the system. I'll be looking at the use of PureGuard 2 and the active flow control attachment. These are especially important as the number of alternative and potentially damaging substitute refrigerants on the market continues to multiply. We're told a number of PureGuard 2 units have been damaged as a result of being flooded with oil and liquid refrigerant. This flooding can be caused by incorrect service procedures or by unique AC service conditions that occasionally arise. Then I'll show you some new materials and equipment for dealing with the buildup of mold and mildew in the AC system and the odors associated with that. Also, I'll be discussing some AC-related conditions that have recently arisen in the field. As I mentioned, for our Diagnosis segment, our location crew visited a dealership. We traveled to Keffer Buick in Charlotte, North Carolina, where the weather is usually a little warmer than around here. While we were there, we got some diagnostic tips from technician Ed Graham. Ed was a finalist in the National Buick Best Technicians competition. Ed described how a lot of times the cars brought in for AC service are actually functioning normally.
That is a common thing for people think it's not cold enough, and it's hard to judge sometimes if it's normal or if it does have a problem. Of course, look it over first to see if there's anything obvious, but if it's close, it's hard to tell exactly what it's doing. Usually what I do is try to use a thermometer in the car and go drive it and try to drive under about the same conditions in every car and get an idea of what's normal for this area under, about typical conditions. You have to allow for if the weather's hotter or cooler. But you can get use the same blower speed and use the same recirculator knot, and you can get a pretty good consistent temperature reading for what the air outlet temperature should be. Or a lot of times just explaining to them that the air conditioner can only do so much in relation to what the outside air temperature is. If it's 100 degrees out, if you can knock 20 degrees off that air temperature, you're doing a lot. And they'll realize it if you explain it to them. A lot of times people realize what it's really doing, not expect it to throw ice cubes at them when it's 100 degrees out. Once you have a good idea there's a leak, the first thing would be to look it over visually as much as possible. The majority of the times you'll probably see some signs of it leaking, of the oil somewhere. All right, just watch the lines, the fittings, look for anything obvious, oil around the pressure switch. Follow the line all the way down to the compressor. Look at the hose ends down there and the switch down there to the compressor, and then follow it back up to the condenser. Look down the side of the condenser, see if anything looks wet there. Look at the front of it for any damage, any signs of anything wrong there. And follow the other line on back up to the case where it goes under the core. Look at those fittings. See if it has any signs of damage. Probably one of the most common is low freon, making the compressor sound almost like a bad bearing in it, real roar type noise on the compressors that run all the time.
As Ed mentioned, low pressure and leaks continue to be the main causes of AC complaints. In fact, due to the higher system pressures, R134A has a 30% faster leak rate than R12 did.
On the 134, you can go ahead and hook up the machine and evacuate the system and see how much freon comes out of it. That gives you a good idea of how bad a leak you have and what your starting point is. and then you can go ahead and put a vacuum on it, and that gives you an idea of how much, if it holds vacuum or if it doesn't, if it leaks off fast or if it holds it. If it holds vacuum, it normally won't have much of a leak. You can then, after that, go ahead and put the Freon in it, the required full charge of Freon in it, and then you can check it with a leak detector and have a better chance of a leak showing up with the full amount in it than when it's only partially charged. Especially something difficult to find like an evaporator will show up easier with the full Freon in it.
The halogen leak detector remains a very effective means of testing R12 and R134A equipped GM cars.
Okay, and then you want to take the leak detector and go around all the fittings or any possible place you might have a leak or suspect you have a leak. Around the switches. Just follow the system all the way from one end to the other. Follow down all the lines. Down to the compressor. Another switch down there. Follow the line back up to the condenser. Down the side of the condenser and the pipes. Back up the other line. Back to the core. Check all, especially the fittings and anywhere the line you can get to. Okay, to check for evaporator leak, the best thing is get the resistor out of the way, and that gives you access right to the core itself. First look at it, see if there's anything obvious. If not, take the leak detector and go all around the core with it. You can go all over the front of the core and over to the corners and up the sides and see if it picks up anything anywhere. And if it doesn't pick up anything, you can still check it for a small leak by leaving the probe lay down in there near the core for a few minutes. And sometimes it takes a few minutes for enough Freon to leak out for it to pick up. And you just leave it sit and see if it goes off by itself like that. Look everything over from under here, the compressor and lines. Make sure everything's dry. Switch in the back of the compressor where the lines bolt on the back. Look at the compressor clutch. You can see everything a lot clearer from under here. The lines where they rub the frame. And from underneath the car, you can take the leak detector, get all the lines around the compressor, go over them, the fittings, the metal lines, check the seals in the back of the compressor, the switch, all underneath the compressor. Also around the front, although if you hold it right at the shaft seal, you might get some indication of a leak, but you shouldn't get much around the outside part. You can find quite a bit by just looking it over, really. That's why I would do that first, because sometimes it's something obvious. If you see, looking for the oil, of course, even the 134 oil will usually stay on there if it's not someplace that gets wet a lot. So I would do that before I would start doing anything else. Look for the most obvious things first, and plus get a general idea of what the system's doing and what kind of pressures you have. Then put some gauges on it, see what kind of pressure you have. But it's you just have to go through the process of eliminating things and looking for the most obvious things first.
You may recall in Know-How 207, I showed the battery-powered D-Tech electronic detector. The device offers a modern alternative for those who want the most advanced technology. I also demonstrated the use of the leak dye injector. The dye is particularly effective in tracing slow leaks that don't show up right away. Also, as Ed said, R134A leaks are more difficult to see as the light oil is often washed away by condensation. When you can't trace a leak with a detector, Inject the dye and have the customer bring the car back after about a week. The dye works best when it's used in conjunction with a black light, and the colored enhancement glass is provided by the light manufacturer. The colored glasses really do make a big difference in how easily you can spot the dye. After the customer has driven the car for a while, the dye should clearly show the location of any leaks. Now, let's move on to the refrigerant recovery and recharging procedures. For this portion, we traveled not too far to a local community college that participates in the ASEP training program.
Hi, welcome to Macomb Community College here in Warren, Michigan. My name is Bruce Hartung, and I'm a General Motors Automotive Service Education Program instructor here at Macomb. The General Motors program is offered at 50 colleges internationally. Now let's quickly review the ACR4 recovery process. First thing we want to do is go over to the ACR4 on the high side, the red hose, and close the coupler, and also the blue hose and close the low side coupler, and remove both of these. And now we're going to go over to the car and install the high side hose to the coupler. And now open that valve. We're going to take the blue low side hose now and install that on the low side line. Now I want to open that coupler. Now that we've connected the high side hose and the low side hose and we've opened both the couplers to the system, I want to go to the ACR4 control panel here, and I want to look at the high side gauge and the low side gauge to determine the amount of refrigerant in there. If it shows 0, that indicates that there is no refrigerant in the system and recovery process isn't really required. As it shows on this gauge, it does show that there's a charge in the system, so we are going to have to recover the refrigerant. The next step then is to open the high side gauge on the control panel and the low side gauge on the control panel so we can begin our recovery. Now that we have all our service lines connected, we'd like to go to the ACR4 and check to see if there's any oil left from the previous repair. Slowly open the oil drain valve to check if the oil separator contains oil. Allow any oil to drain into the catch bottle. In this case right here, there is no oil, so we'd like to continue on. We'd like to plug in the power supply here to the appropriate outlet, turn on our Pure Guard machine, and allow it to go through its warm-up procedure. Now what the Pure Guard is doing is it's going to take a sample of the existing refrigerant in the vehicle. If the refrigerant is approved, the Pure Guard 2 then will turn on the ACR4. Now that we have the ACR4 hooked up and ready for recovery, we'd like to start the engine, run the blower on high. We may want to install a battery charger onto the vehicle to prevent excessive drain during this process. We'd like to go over to the ACR4 and push recovery and begin our recovery process. During the recovery process, the machine is going to be clearing the lines. That process takes 30 seconds to 3 minutes. During that process, the letters coming up on the panel will say CL-L. The ACR4 separates the oil as it operates. The flashing oil ounces is a reminder to always drain the oil from the system at this time. Often, no oil at all is recovered. The important thing is to make sure that the same amount of oil is replaced as was removed. Dispose of the recovered oil is very important. Do not attempt to reuse that oil. Now we'd like to take a look at the low side gauge to make sure we maintain a vacuum in the system. And that's an indication that the refrigerant has been fully recovered from the system. If there's a rise in the pressure on the low pressure gauge, that's an indication that there's still refrigerant left in the system. Push the Hold Continue button to continue the recovery process. This may take a couple times in order to achieve and maintain a proper vacuum in the system, indicating the system has been fully recovered. Before evacuating the system, we'd like to check the ACR4 tank unit to make sure that we have the correct amount of refrigerant to recharge the system. In order to do that, we would hit the Shift-Enter keys simultaneously. The 7 key, shown on the panel display here, will give the amount of refrigerant remaining in the tank. If that tank level is below 8 pounds, we're going to have to refill that tank with the correct amount of refrigerant so that we can continue our process of recharging the system. Press the vacuum key on the panel to start the vacuum pump. A predetermined time of 15 minutes will show on the panel. We can get a longer time of 15 minutes if desired.
Never shortcut the 15-minute vacuum process. If you recover sooner, chances are you're going to put air in the car.
During the evacuation process, the ACR4 automatically recycles the refrigerant through the filter dryer. It also purges air and any other non-condensable gases from the system. You may hear the sound of pressure releasing as the system vents. Tank pressure also increases during evacuation, allowing more efficient charging of the vehicle. Remember, the moisture indicator on the unit control panel must be green. This verifies the moisture content of the refrigerant is within specifications. The yellow indicator indicates a wet condition and requires that the filter dryer cartridge should be changed. You can use the control panel gauges to check for leaks during evacuation. After the vacuum pump has run for about 3 minutes or more, press the Hold Continue key and read the low side pressure gauge. A reading of 0 on the low side gauge indicates a major leak in the system. The repair has to be made before we can continue on with the evacuation process. If 27 to 30 inches of vacuum is indicated, close the low and high side valves and observe the gauges to see if the vacuum holds for a few minutes. If the pressure drops off, find and repair the leak before continuing. If the vacuum remains steady, open the high and the low side valves, push the continue button, and the evacuation process will continue. When the programmed time is up, the display will indicate complete. Now we've come to the actual charging portion of the operation. We'd like to close the low side valve, open the high side valve, and push the charge button on the panel to make sure that we're in the correct programming mode. Use the keys to enter the specific weight of refrigerant required to charge the vehicle's AC system. Press the Enter key. When you press the key, the display blinks to indicate the charge amount has been entered into the unit's memory. Press the charge button to begin the automatic refrigerant transfer.
Be careful not to bump the ACR4 while the charging process is going on. Remember, the ACR4 measures the charge by measuring the weight of the tank. If the tank moves, the measurements mean nothing.
When the display shows complete, close the high side valve. Now both the high and the low side valves are closed. We'd like to start the engine, turn the air conditioner on, let the system run until the gauges stabilize. Check the evaporator to make sure that the system is operating properly. Now it is time to clear the hoses, and this is very important.
When you close and disconnect the high side, then open the valves, all the refrigerant in the hoses is drawn into the car. As Bruce said, clearing the hoses is important. If you don't follow this procedure, as much as a ½ pound of the AC charge could be left in the hose, leaving the car short by that much. The low charge could cause the compressor to make noise, and you may end up replacing it unnecessarily. Plus, you possibly may unknowingly add the ½ pound or so refrigerant remaining in the hoses to the next car. Remember, it won't show up on the control panel because the ACR4 weighs the refrigerant that's in the tank. As we saw, Bruce was using the PureGuard 2 unit on the ACR4, and although we turned the system on and off many times to shoot our video, it performed without any problems. The system takes only a short time to warm up and quickly reads the type of refrigerant it samples. Be sure the yellow hose from the PureGuard 2 is attached to the yellow fitting on the ACR4 and not to the tank. You may find the fuse blows in the PureGuard 2 when the ACR4 vacuum pump turns on. This means the vacuum pump is drawing access current and needs to have its oil changed, or alternatively, the oil level is overfilled. For proper operation, vacuum pump oil should be changed after every 10 hours of use. To guard against contamination of the PureGuard 2 from oil and liquid refrigerant, the active flow control device was shipped to all GM dealerships. The AFC must be installed and used properly to prevent damage to the unit. Always recover refrigerant from both the high and low side of the vehicle's AC system at the same time. This shortens the time it takes to complete the recovery process and ensures the maximum amount of refrigerant is recovered from the vehicle. The PureGuard 2 is designed to sample refrigerant vapor from the low side of the AC system during recovery. A pressure switch in the high side enables the unit to sense when an attempt is made to bypass the purity test. When pressure is sensed in the high side only, an alarm sounds and power supply to the ACR4 pump is shut off and recovery is halted. When 30 psi is sensed in the low side, power to the vacuum pump is restored. There have been reports of incidences when the PureGuard 2 has been removed from the ACR4 because the red excess air light remains illuminated. The light indicates high levels of air are detected in the refrigerant storage tank. The warning does not interfere with the operation of the ACR4. The pressure caused by high levels of air in the storage tank may slow down or in some cases stop the recovery process. This is not due to the warning system. As I mentioned in Know-How 207, the ACR4 operates a lot more efficiently when excess air is purged from the tank before charging a vehicle. A quicker method of purging air appears in the reference manual with this program. You can gauge pretty closely how much air is in the tank by checking the pressure of the refrigerant tank against the ambient temperature where the tank has been stored. Let's say, for instance, the tank has been sitting in the shop overnight at a temperature of 70 degrees Fahrenheit. The pressure of 134A at 70 degrees should be 71 psi. So if you get a reading of, say, 90 psi, then you know you have about 20 pounds of air in the tank. I mentioned at the beginning of the program some new equipment is available for dealing with odor problems that occur in some AC systems. These odors occur particularly in warm, humid areas. Condensation that forms on the AC evaporator causes the growth of mold and mildew. A new generation electronic evaporator dryer module is being introduced. Like the previous dryer module, the first appeared in 1986. The new unit automatically cycles the vehicle's blower motor in order to dry problem condensation from the HVAC system. However, the new design offers many improvements over its predecessor, not the least of which is its small size and relatively simple installation procedure. Notice there are only 4 wires to hook up, as opposed to the 8 on the earlier design. And you won't need a set of wiring diagrams to figure out the wiring. The simple schematic on the unit is all you'll need. Let me show you. The red wire goes to a hot at all times power supply that can handle the 25 amps needed for blower operation. Use the mechanical connector that's provided. The green wire goes to the body ground using the supplied lug connector. The other 2 are spliced into the blower motor's power supply so the module can control the motor with the ignition off. The yellow wire goes on the battery power side and the blue goes on the motor side. The universal design fits all Buick models and the small size module is easy to locate near the blower with the Velcro mounting provided. The module features a test probe check port with an LED that lights to assure the module is hooked up correctly. A fuse also protects against damage from incorrect hookup. The module is designed so it does not excessively load or run down the battery. A voltage limiting circuit will not turn the blower on if battery voltage is below 12.5 volts. The module is designed so it operates on pulse. If you recall, the old system waited 45 minutes, then ran continuously. The pulse system waits 30 minutes, then runs 10 seconds, stops, waits 10 seconds, then runs another 10 seconds. This cycle repeats 10 times. A thermocouple prevents the unit from operating the blower unless ambient temperature is 60 degrees or more. The production version will come with 2 labels to alert subsequent technicians that the unit is installed. One label should be attached to the blower motor, the other on the car body. In addition to the new dryer module, air conditioner treatment is now available in smaller non-aerosol bottles with an application nozzle that hooks up to your shop air hose. Available through Delco, the air conditioner treatment contains an inhibitor that prevents mold and mildew from growing. Remember, when spraying the evaporator core, it must be absolutely dry for the conditioner deodorant to work. Start the car and run the blower motor on high to thoroughly dry out the system. The liquid actually dries to form a seal that helps prevent condensation from sitting on the surface of the evaporator. Be sure to wear protective gloves. Remove the blower motor resistor to gain access to the evaporator and cover the opening with tape. Cut a small hole in the tape for the applicator nozzle and spray thoroughly with air pressure set at 50 to 55 psi. Reports have been received concerning the dual-zone HVAC systems on 1997 and 98th Century and Regal models. Some owners may comment on an inability to control temperature. There may also be diagnostic trouble codes present, codes which, I should add, do not appear in the service manual. These DTCs are B0361, 0363, 0365, and 0367. The situation is caused by the HVAC case allowing the air mix door to over-travel its position. To correct this problem, the HVAC case must be replaced. Some owners may also comment on differences in side-to-side temperatures on manual, single, or dual-zone systems. Remember, this condition can be caused by insufficient refrigerant charge. If the system is properly charged, the difference may be due to an incorrect control head being installed. Another condition I want to mention occurs on Regal models. It happens when the ignition is shut off with the blower motor on the high setting. When the ignition switch is turned to crank the car, a puff of air is felt from the blower ducts. This condition is normal and no repair is necessary. And that's all we have time for in this program. I hope you'll find this information helpful through the coming summer. See you in the next Know How.